Okay. So now we have we start having people coming in. This is great.
Are you seeing people coming in already, Menchi?
Yes, yes.
Okay.
You can click on the participants bar. We're seeing people.
See.
Yeah.
I see that, yes.
Yeah.
I see some people that I know for a long time already. Bengt Sunesson. Welcome, everybody.
Good morning, good afternoon.
Yeah, names that I know. It's good. Thank you all for joining. Weet ik. Okay, welcome, people. I see people taking part in the webinar now. We will wait a couple of minutes for the webinar to start, to allow some more people to attend.
Also from my side, here's Stefan speaking. Thank you very much for joining. And as Leon mentioned, we want to wait a couple of minutes that everybody get the full package of us. So a couple of minutes we have to wait. And we are happy that you're joining our webinar.
And slowly we're getting more attendees. Good. Slowly getting there. We'll wait another couple of minutes, guys, for it to start, because people are still calling in. Okay, we'll wait another 2 minutes, and then we'll.
Okay, I'm fine.
Yep. Cosmin and Stefan, fully ready?
Ready.
Yes.
Okay, cool. And people are still calling in.
Mhm.
Looking good. Wait just a little more. Mengchi,
I think we
we
should be
should-
good to go.
we should start. We are 3 minutes past 10. Do you agree?
Let's go.
Yeah. Okay. Okay, to all attendees, good day. Thank you very much for joining and for attending our webinar. Most of the names that I saw in the attendee list know me, I think. My name is Leon de Ridder. I'm one of the owners of Cisper, and I'm hosting today's webinar, actually co-hosting it with the people from Energous. So let me shortly, first of all, introduce Energous and Cisper to you. Some of you may not know Energous. It's a relatively new company that we have recently partnered with, and they are specialists in RF-based charging solutions. And we like to describe Cisper ourselves as a specialist distributor for RF auto ID technology products. We have so far focused on UHF RFID, and we are officially representing several high-quality vendors of this kind of products in UHF and BLE. So since about a year, and Stefan, can you please go to the next slide?
Mhm.
Since about a year, Energous and Cisper are working together on the distribution of the Energous RF solutions in Europe. And in today's webinar, we will focus on how Energous technologies can enhance the Wiliot BLE technology. Well, as the title of the presentation of the webinar already suggests, we aim to give you more information about how we believe asset tracking can be revolutionized by using Energous wireless power over the air technology. So today, an introduction to Cisper, a short introduction, Energous at a glance, that will be handled by Stefan Bertman from Energous, and Cosmin Pascu, who will stand by for technical support and also for the Q&A session. We will say something about the Pixel, the Wiliot Pixel, that is the power bridges from Energous that can be used to power up the system, and the whole system of Wiliot as a complete set. And I will mention something about how to get started and get your hands-on products. So let me now hand over the presentation to Stefan and Cosmin technical support. So please fire ahead, Stefan.
Thank you, Leon, for the introduction. Hello, everyone. My name is Stefan Bertman. Thanks for joining this webinar with the Cisper team, and my colleague Cosmin and I will be introducing the new asset tracking solution for you. Cosmin and me, we are based in Europe, more or less in Central Europe. So I am based in Munich, in Germany, and Cosmin is based in Romania. And we are here a team of 3 people, Energous Europe, to help you, to support you. If you have any questions, even also in the Q&A, we'll be happy to answer this. First of all, for those who are not familiar with Energous, we are a wireless power network provider with the focus on IoT markets. Our mission is really to bring unlimited coverage and, of course, help to increase the data efficiency to everyone. Enabling sustainability IoT with more flexibility helps to get informations on more devices. It's very important to get certified for radio transmission, and I will go on my last slides also on this very important topic, but we are mostly certified all over the world. Therefore, we are working to unleash higher power and to increase the numbers of edge devices and bring it also to artificial intelligence. But last but not least, we want to save our environment and helps to reduce the cost of changing disposable batteries, and means also reducing the cost of service if an engineer has to change the batteries or put in an USB connector to charge a device. Right now, Energous is focusing on 3 main applications. On the left side, partnering with the world leader in space, in each space. For asset tracking, our lead partner is Wiliot, when we will talking more in details in this upcoming presentation. And we work also with E-Link on electronic shelf label solutions together. And last but not least, we are supporting also sensor companies like Sensirion and AMS Osram to power on IoT sensors without any battery. So Sensirion is probably known for CO2. With the AMS Osram, we developed already a solution that have light measurement, light temperature measurement, spectral light measurement, and all these sensors that's coming up. And this is even also a growing market with the vertical agriculture. That could be interesting also for you to think about how to attach different kinds of sensors to let it run with wireless power transfer. Just an overview, the different from some of the contact wireless power transfer technology is known, the key standard, where you have a magnetic coupling, but also Energy is not only lead innovator in power over long distance, but also key contributor to the industrial standards. And one of these standards is Air Fuel Alliance, and we are part of this alliance, and our technology is an Air Fuel interoperable solutions. With that, I will now take you to discuss our today's topic, a new way of asset tracking powered by Energous and Wiliot technology. First of all, what are the current challenges in asset tracking? First of all, the tag readability is most of the common requests. The ideal solution is to read a tag in 100-meter distance, and it should be cost no money and everything. That's the dream world of a lot of logistic companies, but unfortunately, we are not so far in the moment. Secondly, we've developed already that the TCO is very important and has to be reduced in all these solutions. Nowadays, more and more sensing information has to become more valid. It's not just only a temperature measurement, it could be humidity, and these dedicated is primarily for vaccine shipment, for medicine shipment that has to be cooled down. Or on the other hand, cold food logistic. Yeah, I give an example. Strawberries, to transport strawberries is really a challenge because it can be so cold and not so warm that it's even spoil. All these things are getting more and more together. It's not just to have a tag available giving some informations, but you need the next couple of years really more informations about temperature, humidity, you can name it. And most of, unfortunately, active sensors that's on the market, like the temperature logger, has really disposable batteries. And depending on temperature, it could last long for 3 months, for 6 months, probably a year. But then it has to be changed. And then the cost of service to go there and change the small battery is not really a solution. And we really want to protect our environment and get rid of these disposable batteries. And in Europe, there will be EU law that will push us in 2025 more in this area, that all disposable batteries will increase in pricing, and you have to see how you disposal these batteries. So there will be coming up in the next couple of years more and more requests coming up. How we can expand the coverage, reducing the costs, and get additional informations will be also part of the next slides. Therefore, I picked up 2 use cases to show the new asset tracking capability. And let's move on these. I would like to guide you through a typical logistic area where to take pallets. You see it on the picture. Mostly all logistic areas using still barcode guns to detect the labels. If now a person is not in a good mood or forget to targeting the pallets, the human error will be copied many times and you will never get the expected accuracy. That's unfortunately given in all logistic areas. And to automate these processes with less human interaction could help to solve these bottlenecks, let's say this way. So in our project, there was a requirement from our client tracking assets at 250 square meters. At least it should be detected 60 pallets. And last but not least, classical, every logistic area needs an in and out dock door detection. And these are the given parameters that we got from the client. And I would like to help you together how we have created a solution on that it makes valid for everyone. Here you see a classical logistic area, overcrowded with pallets, boxes, and this solution you see is really, not really specialized. It's not organized, just putting all the things together. And in this area, you will see on the left side that we installed some transmitters. And these transmitters are in the height and the ceiling mounted and could be covered 10 up to 15 meters, all these cartons, pallets with the transponder, and to get back the feedback that's in a dedicated area stored. So this alone helps the client to identify the tags and to see, okay, where is my pallet now? It's near to the end on this location. And this is really helpful, or this was a really helpful solution for them to detect all the things. The second part of this was really also asking for a dock door solution. That means the in and outgoing pallets, cartons has to be detected on the dock door. And then we placed, as you see in the middle, also a transmitter and helping to read the incoming and outgoing goods. Parallel, do the 10-15 meter reachable We have also tracking on the entrance the pallets very easily, and can filtering by the software that these are static and not moving. Interesting move we had also, because there was a forklifter involved to put the pallets into the logistic area. And at least we can make it with 8 meters per second, and that's a slow forklifter. But in these projects, you have really to think about how this is going to work with faster moving forklifters. And I tell you, the drivers of forklifters have no time, and they make a kind of rally in the logistic hall. So in this use case, we really detected with a few sensors these requested 250 square meters area. The solution is just 3 Energous transmitters. We get 99% read, nearly 100% read. The interesting stuff, and I will go in the next slides about our technology, we don't need any cable. So the only cable that we need is to power up our transmitter. There is no network cabling needed. There is no antenna cable needed, or different antennas to reach that. And it's not needed that you have to build up a really doctor solution with readers, with a few antennas to detect the in and outgoing material. And last but not least, that was also a smaller request from this client, was saying, I would like to have this information available on a mobile device. Could be the mobile phone, could be a tablet. Mostly our forklifters has it on the tablet, on the forklifter. So that was a side effect that he was looking for that. After this testing and satisfaction of this client, he came up, yeah, we have also some trucks delivering some cartons, and that's not our own company, it's a freight forwarder. And sometimes he has different goods on his truck. And then we said, yeah, let's talk to this truck or this freight forwarder organization. And then we did a test, adding 3 more of our bridges to detect all the goods are on the truck. And then we built up also a kind of specialized gateway to communicate from our transmitter to a gateway. This allows with LTE and additional also GPS to check where the truck driver is and which goods are going to the next distribution store. You see it on the truck, on the orange cartons or pallets. So we can really detect all these interesting movements. And yeah, that's helped also this logistic area to get the right data and time savings if you load your truck in the right order, not to unload before you can access to the pallets. So that was a side effect, and this went also well. And this will be was very interesting. Of course, in the truck there are more specific things coming up. So there was a request of ruggedized housing. Means yeah, it should be running at minus 40 degrees and plus 60, 80 degrees. So, and we are just in the phase to develop a housing that meets these requirements, means the requirements on industrial style and even dust protected, probably not really water protected, but a kind of protection as well. And probably also the vibrations is very critical if you put these transmitters on the truck. Secondly, I would like to go on a different world to show you another use case that we have done, and also it's already working in the other part of the world, in Australia. And a question that always comes up, how useful it could be to order a t-shirt online and pick it up in a retail store and find the right rack with the blue color in your right size. These questions are always coming up, and yeah, is that now a future project? No, it is not, because with that solution on the next slides, I will show you how this is going to work. And similar to the logistic in and out, it's more or less in the retail shop the same situations, and I would like to come to you to some differences. Here you see this shop Academy brand in Australia, and as you see in the ceiling, we put also our transmitters, and on this shirt you see then also the tag is mounted to be detected. And if we're going now on the requirements, similar, tracking apparel within 300 square meters, similar to the first use case. But interesting wise, they want to track 1,000+ items to be tracked. And of course, they have a small storage room in every shop. And similar to the doctor solution in logistic, they want to check also the in and out of this small stock in the shop. So what we did, when Joe go for the next slides, is as well, we're adding our transmitters on the ceiling. And as you can see, it's not just 3, we added more because the infrastructure of this shop contains more metal. The racks are different sizing and everything. And we decided to be sure that we are really using 8 Energous transmitters in this area instead of 3 in the previous slides. So we achieved as well 98% tag readability. And the most impressive feedback from this client was that they have a real-time inventory accuracy. And the new terms is user experience. As I mentioned before, I can sit on my couch ordering a shirt and go to the shop and try it and use it. And this user experience has to be related mostly to a mobile device. So it will be nice if the customer gets the information. It's in the shop in Melbourne, in your size available, you can pick it up. All these stuff from the plain logistic and inventory, it comes to more and more complex with user experience and putting more features on this technology. And we are not talking about the cache area and everything. So there's so many possibilities in this kind of solutions that we just scratched on the surface. Okay, now this was part of our daily work. I would like to go now a little bit more in technology. And I would like to explain you in the next few slides how our system together with Wiliot is working. And I'm just switching over to, on the left side, you see the Wiliot tag. And a Wiliot ecosystem works with passive tags. It's called Pixel and must be energized over the air. These tags are equipped with 2 separate energy harvesting interfaces, and you see it probably on these coils, longer and 2 smaller coils, and tuned for operations in the sub-gigahertz and the 2.4 gigahertz bandwidth, respectively. And consequent, in order to achieve optimal performance, the wireless power transmitter is designed to send RF power over these 2 channels. And I will show it you on the next slide. And when the tag accumulates sufficient energy to sustain an error-free transmission, it will be fired out over the BLE interface and data package containing a unique identifier number and also a temperature measurement, or in future probably other sensor data will be transferred through the BLE communication. And then the harvesting broadcasting cycles repeats for every tag that's detected by our 1 watt Energous transmitter. I put it now a little bit together. The Energous bridge or transmitter is continuously sending out RF energy in the dual frequencies, as I mentioned before already, UHF and 2.4 gigahertz band, and helps to energize the pixel. This is in critical environments helpful to detect tags and their position and extend the read range up to 15 or more meters. After the chip is responding and connected to the 2.4 gigahertz BLE, it's established all informations and could be exchanged to the bridge. And it must be understood that the BLE signal broadcast by the tags are really weak signals. That's not a lot of energy and everything. So in order for them to make it all the way to the internet access point or a gateway, they must be retransmitted in a higher power level. And that's why we came again in this role, and our Energous transmitter is capable to do this. And this function of the power bridge is known as signal echoing. So as soon the tag data packages are reached out to the gateway, then are published further into the Vilyot cloud for the decryption, authentication, and of course, interpretation. And that's a general work. Last but not least, and now you have the full picture how this works. Once the data are in the Vilyot cloud, you can access as a partner, as a software developer, as an end user, and you have different interfaces that makes this data available. And one of this well-known IoT protocol is MQTT, and we are supporting over HTTP as well REST API. And REST API is one of also well-known protocols that you can build up your own application and can handle this data. And finally, the user can use these data, these informations, and help. So what we did in the last couple of 3 months, all this is a really complex area just on the presentation, and hopefully you understand what I'm told. But to make it easier for you, we are just providing also a complete setup guide. And Cosmin will send this link into the chat group, and then you can really read more details, how to set up the software, how to set up the transmitter, how the communication protocols are working, more technical details. And this is also probably helping you for doing a good solution in this conjunction. Even also some hints and tips and tricks how to mount this Energous transmitter, which position is the best one to get the dual billion pixel tag energized, in which distance and everything. All these informations Cosmin will provide you in our chat. And of course, you will get also a download link that you can go to Cisper and to Energous to download it as well. Cool. Just an overview about this transmitter. Energous was originally developed this transmitter for sending out energy via radio frequency for IoT sensors. As I mentioned in my beginning slide, it was a CO2 sensor that needs no or runs without any connector or battery. And a couple of years ago, Vilyot came up to us showing us the new BLE technology. And up on that, we developed then these video transmitter specialized in these 2 frequencies to really have an optimum and charging capabilities that we can go beyond 10 meters to detect these things. In summary, you see the key features again. We have a sub 1 gigahertz and 2.4 gigahertz energizing signal. Our transmitter is also has a good repeater function to the next stage, to a gateway, to get the real power. It's a dual polarized sub and 1 gigahertz and 2.4 gigahertz antennas to energize with more power. In the near future, there will be coming up more products, as I mentioned, the ruggedized housing. And probably if everything will smooth running with all the developments and the certifications, then we will extend also the power from 1 watt to 2 watt. And probably we can extend then even more the distance and detecting more of this Williot pixel tags in some use cases. I would like not to forget, and this is a real interesting part, is in radio frequencies, you have all over the world regulations. In the US, it's FCC. In Central Europe or in Europe, it's ETSI certification that you're allowing to use some frequencies, some power levels. And one of our, before we sell a product, we are assured that all our technology is really certified. And just to see on this map, US, Canada was the easiest because we are based in US. So we had earliest the FCC, but later on the EU certification came along, Australia, New Zealand, China is also an important part, South Korea, India, and last but not least, and the complicated regulation is really Japan. And we got this 3 months ago. So we are really sure that if you buy a unit that's certified and you have no worries, that's running under some conditions that doesn't help. Okay, so I would like to hand over again to Leon, because I think we have a nice announcement to do to helping you also get familiar with all these solutions which I presented now. And I would like to hand over to Leon, please.
Okay. Yes. So as Stefan already said, we believe it can be interesting for you to get your hands on testing these products. And for that reason, we have prepared 2 kits. One that we call an entry kit for your initial testing, containing a power bridge, 50 pixel tags, and the instruction leaflet that Stefan just mentioned that we have prepared. And if you want to do a small POC and really get some experience on how the system works and use more power bridges for locationing, for example, we have one with 4 power bridges, 250 pixels, a Williot certified gateway. And we have that available from Cisper here in Almere in the Netherlands. I already saw some questions, so I think that there may be some people that are interested in those kits. And they are available here. As I said, you can contact us at info@cisper.nl, but you can also get a hold of me and I'll get back to you straight on. Yeah. So I think,
cool.
Stefan, that brings us almost to the end of the presentation.
Yes, of course. And we have now time for doing some Q&A. And I think Cosmin will jump in and answering some questions that came up from your side. if we not get an answer here online, then we will open to send you an email and contacting you for more questions, of course. Otherwise, we run out of time, and that could help us as well.
Yes.
Just, yeah, let me jump. Oh, no, I missed one slide. Sorry. Just to summarize all the things, what's revolutionary technology is really reducing the amount of the hardware. We are simplifying the deployment with robust BLE connectivity, and this is really a game changer. Of course, all these data coming from the tag is really secure encrypted. And as I mentioned before, there is now already integrated temperature tracking included, but there will coming up more sensors on the roadmap, like humidity or acceleration sensors. And you don't need for this tag any battery for this sensor measurement. It's already included on this pixel tag. And of course, as I mentioned, with this technology, the readability range is really extended to other known solution in the market that I'm aware. And that helps also with the dual band frequencies, UHF 900 megahertz and 2.4 gigahertz. Okay, just a summary on that. And now I will heading over to Cosmin to give some answers and question and answers.
Yes, thank you, Stefan. And while you were presenting, I can tell you that the audience was very active, and we received a number of good questions here. So, well, what I did was to categorize those questions onto different topics in order to provide, you know, a wider coverage for these questions. There was a category of questions related to the operation range, and as you also mentioned before, the range that this system is capable to achieve goes to 10 meters and beyond. Of course, it also depends on the optimal alignment between the tag and the power transmitter, but pretty much this is the range that we can achieve. Now, about the operation range, it is important to understand that it is on both the communication partners. It is both the communication partners that are contributing to maximize this operation range. On one hand, the energizer, the power transmitter, is required to send power over the sub-gigahertz and the 2.4 gigahertz channels, as you mentioned before. On the other hand, the tag is required to optimally harvest that energy that is being delivered. In the other way around, the tag is required to broadcast data over the BLE channel. And on the other end of the communication chain, the receiver, the power transmitter, is requested to provide a good receive sensitivity so that the data can be properly extracted from the RF carrier, coded, and further on interpreted and processed. Other questions were related to the user memory, the amount of memory that the tag provides. Well, when it comes to the Wiliot pixel tags, and when it comes to the Wiliot ecosystem in general, the user data is localized in the cloud system, and there is a logical association between the user data and the tag ID. So each time when the system is picking up an event from a given tag, it can make the association with the corresponding user data into the cloud. The tag, of course, provides, let me say, local memory as well. If we talk about the Wiliot ephemeral ID structure that is incorporated into the tag and transmitted each time the tag has enough energy to sustain an error-free transmission. Other questions were related to the data security, and here I should mention that the data going out from the tag to the power bridge and later on to the gateway, all the way to the Wiliot cloud and then to the end user, it is AES 128 encrypted. And going to the next question, somebody from the audience asking if the server operation is a premise to get this system working. Wiliot Cloud is definitely a central part of the ecosystem because it is the entity that processes the tag data. It is the entity that decodes, decrypts, and interprets the data that is being sent out by the tag. So yes, the cloud infrastructure, the server infrastructure is required. Some other questions were related to the regulatory part, and here I should mention that the system, the power bridge in particular, comes with, I mean, it has been certified against FCC regulatory and ETSI regulations as well. We do not need, you know, a special license for the frequency bands that we are operating. The system is certified and it can be utilized. There was also one other question that I have seen regarding the data throughput and in general related to the time from the moment when the tag is energized all the way to the point where the end user can actually see data. Now, it is important to understand that for the tag data, there is quite a journey, I would say, as you also explained before, Stefan, with the system diagram. We have an energizer, a power bridge that is sending energy over two channels to the pixel tag. The pixel tag is harvesting that energy in small chunks all the way to the point where the storage element, the internal storage element, has enough energy to compute the data that is going to be sent out and to perform the transmission as well. This process takes time, probably in the range of seconds, depending on the distance between the tag and the reader, depending on maybe other environmental factors. Further on, the power bridge is receiving those beacons, and it extracts the baseband data signal from those beacons, and it is also enriching that information with additional data that the cloud will use later on in the localization process of the tag. So this is another part of data processing that takes time. Further on, the data is pushed all the way to the gateway. The gateway is again processing and further enriching the data, and eventually the data, it is loaded into a JSON package that is being delivered to the cloud over an MQTT interface. So the time to first packet that that an end user may see coming from the pixel tag is in the range of seconds. After the first packet it is delivered, the tag will not require probably so much time to rebuild the energy reserves, and the data pacing is increasing within the system. One other question that I wrote down before I started answering is related to dual channel energizing and the dual channel harvesting. Why do we need these two channels? We were talking about sub-gigahertz energizing channel and the 2.4 gigahertz energizing channel. Well, also here, I think we should appreciate one particular thing, that on the higher the frequency is, the higher the free space propagation losses will be. So on the 2.4 gigahertz channel, the harvesting capability of the tag are somehow ranging up to 5 meters. On the other hand, on the sub-gigahertz energizing channel, the harvesting capabilities are basically expanded up to 10 meters and beyond, as I explained before. So utilizing two energizing channel, on one hand, it diversifies the the energy sources for the tag, but it also contributes to the expansion of the operation range in general. Another question that I see right now on the window, it came just now. Can the device be used outdoors? I think it was also you, Stefan, that mentioned before that on Energous side, we are also considering developing industrial casing and ruggedized design, providing protection to various environmental factors like dust or humidity, etc. So definitely we are getting ready for having this device operating in outdoor conditions as well. So
Cosmin, sorry to interrupt. I saw some commercial questions as well regarding pricing. Well, the pricing is always a difficult one, of course. We are still not at the level of a UHF tag. Having said that, it's not always necessary. So depending on quantities, I would say that we are still above €1, and then we're talking high quantities. I also saw a question about the unique selling point of this system compared to UHF RFID. I would say that the most unique point is the fact that much less hardware is needed if you compare it with UHF RFID, and the hardware that is needed is also lower in price. So I think that those two are the unique differentiators from UHF RFID. And then on the signal side, the BLE signal that a tag broadcast is also a more rugged, let's call it a rugged signal compared with an UHF RFID signal. Right. I think, Cosmin, that we have touched most of the questions.
Yeah, I believe so too. Yeah.
I scrolled through it. So I think a good question also here, can a pixel be put on metal? No, not yet. The current pixels cannot be put on metal, but companies like Confidex and Xerify are also partnering with Wiliot, and they are at the moment working on tags for on metal, pixels for on metal and more ruggedized. So that is also on the roadmap, not there yet.
And on metal is always critical. If you do radio frequency, it's always a solution. It could work, it could not work. There are reflection that could help, and there are reflection that's against RFID, even also in the RFID world, right? So on metal is always risky, let's say, and we have really to dig into the deep dive with the use cases, what you want to achieve.
Yep.
And then it's fine for that we can getting new pixel tags with the spacer and everything similar to the RFID world. Yeah.
And a ruggedized housing.
Typically,
Yeah.
this is the recommendation when the pixel is attached to highly absorbing surfaces. A spacer is usually recommended.
Yeah.
So I believe, Stefan and Cosmin, that we have touched the questions. If there are any questions that people may have after the webinar is closed, they can of course contact Stefan, Cosmin, and myself, and we are here to support, and we will respond fast to all your questions. So from my side, thank you very much for paying attention. And for joining our webinar. Stefan and Cosmin, if you want to say something to close it off.
No, I would like to thank everyone for the questions that have been asked. This shows once again that there is high interest in this technology. And also Stefan explained in the beginning, well, this would be the future. I mean, it will be a prerequisite for the IoT expansion in general.
Yeah, thank you.
And I think we should, and thank you also for all these attendees joining us. So there seems to be interest beside RFID, and I think with the new wireless charging of IoT sensors could be also interesting. So if you have any questions, belong also not the Wiliot part, but also the IoT sensoring. What we have done. If you want to share with us a use case or some thoughts, please contact us. And we have a lot of experience, what's working, what's less working. But I think all this world of asset tracking and sensor stuff is coming together. And we're expecting more and more developments also in conjunction with temperature sensors and everything. So please feel open to contact us. We can do a private Zoom call, let's say this way. And we are open-minded and share with you more informations. And of course, Cisper can help you also on these topics. And we are in a team and you get the best what you need.
Yeah. Okay. Thank you very much.
Thank you. Have a
Bye-bye.
good day.
Thank you. Bye-bye.
As we're closing off, I think there is one more question. Can Energous work along without a Wiliot cloud?
No.
Wiliot cloud is a central part of the system, as I explained before, doing the data decryption. The data is AES-128 encrypted, so it is the Wiliot cloud entity that does that decryption. Yeah. Thank you.
Thank you. The recording will be available online, and we will send a follow-up email to everyone. Thank you very much.
Bye-bye.
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 Bye.